Okay, guys. Okay, we're going to go over lesson 112, problem solving, model addition and subtraction. Sammy scored 84 points in the first round of a new computer game. He scored 21 more points in the second round than in the first round. What was Sammy's total score? So first we have to think about, what do I need to find? What is the question? So the question is, what was Sammy's total score? So I need to find Sammy's total score. What information do I need to use? Well, Sammy scored 84 points in the first round. He scored 21 more points than that in the second round. How will I use the information? I will draw a bar model to show the number of points Sammy scored in each round. Then I will use the bar model to decide what operation to use. So here's our bar model. Complete the bar model to show the number of points Sammy scored in the second round. Well, in round 1, he scored 84 points. Now we know to get to the round 2 answer, he got 21 more points to that 84. So to find the answer of what he scored in round 2, we're going to do 84 plus 21. I always do this on the side because it's much easier to do the math if it's vertical. 4 plus 1 is 5. 8 plus 2 is 10. So the answer is 105 points. Now, complete another bar model to show Sammy's total score. So, in the first round, we have 84 points. In the second round, we have 105 points. And we're going to add those together to get the total. So 84 plus 105. Now here again, I'm going to do it vertically, and I'm going to use the commutative property of addition, because I'm going to put my 105 first. It's just easier for me to keep organized that way. 5 plus 4 is 9. 0 plus 8 is 8. And 1 is carried down. So our answer is 189. So how many points did Sammy score in the second round? Well, that would be our answer of 105 points. And Sammy's total score is 189 points. Be sure to put your labels. It's important. Okay. Anna scored 265 points in a computer game. Greg scored 142 points. How many more points did Anna score than Greg? You can use a bar model to help solve the problem. So what do I need to find? What's my question? How many more points did Anna score than Greg? So how many more points did Anna score than Greg? What information do I need to use? Anna scored 265. Greg scored 142 points. So how am I going to use the information? I will use a bar model to solve the problem. All right, now we're going to record the steps. So if we look here, here's our bar model that we're going to use for this problem. Anna has 265 points. Greg has 142 points. We need to figure out what the difference is between their points. So if I'm going to find the difference, I'm going to subtract. So 265 minus 142. 5 minus 2 is 3. 6 minus 4 is 2. 2 minus 1 is 1. So our answer is, how many more points did Anna score than Greg? That'd be 123 points. How do we know our answer is reasonable? Well, if I go back to the beginning and we estimate like we used to do, I could say 265 is really close to 275, and 142 is close to 150. So an estimate answer would be 125, and our answer of 123 is close to our estimate of 125. So we can estimate, and our answers are close. So how did our drawing help you solve the problem? Well, the drawing told me, it helped me figure out that what we're missing is a chunk out of this, which helped me realize that I needed to subtract. So the drawing helped me visualize the problem. It helped me realize I needed to subtract. Okay. Sarah received 73 votes in the school election. Ben received 25 fewer votes than Sarah. How many students voted? So first, we're going to find how many students voted for Ben. So we're going to think Sarah's got 73 votes. Ben has a mystery amount of votes, but we know this chunk that makes up the difference is 25 votes worth. So we're going to think 73 minus 25. Oh, here I wrote my 25 in the wrong spot. So 73 minus 25. Well, I know 73 is really close to 75, so I think 75 minus 25 is 50. So I know it's going to be close to that. But I'm going to borrow from my neighbor. 13 minus 5 is 8. 6 minus 2 is 4. So Ben had 48 votes. Now, write the numbers in the bar model. Ben received 48 votes. Next, find the total number of votes. So we're going to write the numbers in the bar model. We're going to do Sarah's 73 votes and Ben's 48 votes. And that bar model tells us we need to combine these together. So I'm going to think addition. 73 plus 48. 8 plus 3 is 11. Carry my 1. 8 plus 4 is 12. So the total number of votes is 121. Now, if Ben received 73 votes and Sarah received 25 fewer votes than Ben, how would your bar models change? Would the total number of votes be the same? Well, our bar models would flip-flop. They would switch. Our bar models would switch, comma, but the total would remain the same. Because we're using the same numbers. So if we look here and we think about this. So if Ben was the one with 73 votes and Sarah was the one with less, they would have a different amount of votes for each person. However, when you added them together, you would still have Ben as 73 and Sarah would have 48. So we're still using the same numbers, so we're still going to get the same total. Now, what if there were 3 students in another election and the total number of votes was the same? What would the bar model for the total number of votes look like? How many votes might each student get? So we can have a couple different answers here. So I'm going to go ahead and I'm going to draw a bar model. I'm not going to use it on the lines because it's easier for me to draw it on the side. So we're going to do just like the bar model we see up top. Okay. If we know that the total number of votes is 121, the only difference is instead of us cutting it into 2 pieces, we're going to cut it into 3 because there are 3 students now instead of just 2. So they ask how many votes might each student get. We can get a couple different options here, okay? We can split it up. We could say, wow, one student had a lot more votes than the others. And we could say one student had 100 votes, which would make this box actually a bit bigger. And if that student had 100 votes, 121 minus 100 would give us 21 more votes. And we could say one person got 10 votes and one person got 11 votes. Because when you added all those together, you get the answer of 121. So over here, I'm going to say student 1 got 100 votes. Student 2 got 10 votes. And student 3 got 11 votes. Now, doing this problem, this is just how I broke it up, because in my mind, I like taking that 100 out, and it just made it easier for me to come up with an idea. But there are many, many other answers you could have gotten here for how many votes each student could get. You could have said one student had 50, another student had 50, and one student had 21 votes. There are a bunch of different ways to get to the answer of 121. Okay, pose a problem. Use the bar model at the right and write a problem to match it. So here, if I look at this bar model, they're giving us a total and they're giving us a part, and we're missing a part. So let's write a problem that starts with a total. We'll use the name Chase. Chase has 157 stickers. He gave, here we're going to use our part, gave 89 to his friend. Now we need to come up with a question for a part. So a question that would work would be, how many does he have left? So we're going to solve our problem, and they want to know if we're going to add or subtract. Well, if we have the total and we need to find the missing piece, so we're going to find the difference between the total and a part, we're going to subtract. So we're going to do 157 minus 89. Sorry, it's hard to erase with one hand, so I'm videoing with one hand, so that's sloppy. So I'm going to write this vertically. 157 minus 89. Well, I'm going to have to borrow That makes it 17. 17 minus 9 is 8. I'm going to combine these place values and just do 14 minus 8, which is 6. So our answer is 68 stickers, because we still need that label. Now, Tony's Tech Store had a big sale. The store had 142 computers in stock. During the sale, 91 computers were sold. How many computers were not sold? So I'm going to draw a bar model. And just like up top, they gave us a total. They had 142. Okay, during the sale, they sold 91. So we need to figure out how many are left to get back to the total amount that we had. So we're going to do 142 minus 91. 2 minus 1 is 1. I'm going to combine these. 14 minus 9 is 5. So 51 computers. There are 208 people in one movie theater. There are 78 fewer people in the next movie theater. How many people are in both movie theaters? So we can use bar models just like we used in the first problem way back here on page 1. But the way that we're going to switch this up is that there were fewer instead of more. So our first bar model to figure out how many were in the second movie theater, we're going to have 2 bars. So theater 1 and theater 2. So in the first theater, there are 208 people. Now, there are 78 fewer people in the next movie theater. So what I'm actually going to do is I'm going to make this box smaller and just add a little chunk here. So if there are 78 out here, because we're going to take that out of the 208, we need to find out how many people are actually there. So 208 minus 78, 8 minus 8 is 0. I'm going to combine these. 20 minus 7 is 13. So there are 130 people in the second theater. But now we need to find out how many people are in both theaters. So we're going to make a new bar. And we're going to put, we had 208 in our first one. And we had 130 in the second one. So we need to find out what our total number is. So we're going to add 208 plus 130, 8, 3, and 3. So our total number is 338. And that's 338 people. In 1 week, 128 cell phones were sold. The following week, 37 more cell phones were sold than the week before. How many cell phones were sold in those 2 weeks? Okay, we're going to do some bar models again. So week 1 and week 2. Week 2 is going to be a bit bigger. So week 1, there was 128 phones. In the following week, 37 more. So we know that this extra chunk is 37. So we're going to add 128 plus 37. 8 plus 7 is 15. Carry 6 and 1. So this is 165 is in week 2. Now how many were sold in the 2 weeks? So we're going to add again. We're going to do 165 plus 128. 13, carry my 1, 9. and 2. So 293 phones. All right, on Monday, the number of customers in the store rounded to the nearest hundred was 400. What is the greatest number of customers that could have been in the store? So when we round a number, we're either going to keep it at the 100 it's already at, or we're going to bump it up to the next 100. So if we want to know the greatest number, we know that it's still going to be in the 400s somewhere. But remember, if we're rounding to the nearest 100, we're going to look at our tens place to give us information about whether to go up or to stay the same. So the number that would push us up would be a 5 or higher. So we know this can't be a 5 or higher. Well, if we're looking for the greatest number of customers, we need to go to the highest number that we could put here without pushing us over the top. So the closest number would be 4. And then our ones place we can make as big as we want. And we want the greatest number. So we're going to put the biggest number that we could put in our ones place, which is a 9. Okay, so the greatest number of customers could be 449 customers, because if you had 450, it would round to 500. There are 306 people at the fair on Saturday. There are 124 fewer people on Sunday. How many people are at the fair during the 2 days? So day 1, we have 306. Day 2, we have less because it's fewer people. And the difference is 124. So to find out how many people were there Sunday, we're going to do 306 minus 124. 6 minus 4 is 2. 30 minus 12 is 18. So 182 were there Sunday. So to find our answer, we're going to do 306 for Saturday and add the amount of people we had Sunday, which is 182. 6 plus 2 is 8. 0 plus 8 is 8. 3 plus 1 is 4. So 488 people were there both days. All right, guys, please let us know if you have any questions.